Have you ever just stopped to think about how absolutely incredible sight is? I mean, in a split second, your brain takes in this just a flood of light and information, and it just gets it. It's a kind of magic we totally take for granted. But what happens when we try to teach a machine that exact same magic? Well, that's what we're going to dig into.
No, really, think about it for a second. You don't see a bunch of pixels or, a fuzzy blob with pointy things on top. You see a cat. You just know it. How? Well, the answer to that question is not only fascinating, it's pretty much the exact blueprint engineers used to build the digital eye.
So, to understand how we taught a computer to recognize that cat, we first have to look at the original, the unbeatable model, our very own brain. Turns out, nature is one heck of an engineer.
Okay, let's dive into this diagram. I know it looks a little complicated, but what feels so instant to us is actually more like a high-speed relay race. Light hits your retina, and that signal starts zipping along the optic nerve. It makes a few pit stops before finally landing in the primary visual cortex, way at the back of your brain. It's not one single aha moment. It's this incredibly fast, multi-stage process of sorting everything out.
You know, the real secret sauce here is specialization. The visual cortex isn't just one big blob. It's made up of all these different areas. And as information flows through, different little sets of neurons start firing. Some of them might only care about, say, horizontal lines. Others only get excited by the color red. And others are just looking for movement. It's like a whole team of specialists, each doing one tiny job to build the complete picture.
So when AI researchers were facing this huge task of teaching machines to see, they knew that just analyzing raw pixels one by one, that just wasn't going to cut it. So they didn't start from scratch. They looked at the best system in the known universe, the one right inside our own heads, and they decided, okay, let's build a digital version of that.
And that brings us to the absolute star of our show today, the Convolutional Neural Network, or CNN. It's a special kind of AI, a deep neural network that's built from the ground up to process pixel data. And that word, convolutional, that's the key. It's named for the way it mimics how our neurons only pay attention to a small, specific piece of our vision at a time. Now, what's so cool about this slide is you can see just how literal that inspiration is. Just look at this. On top, you've got the biological pathway in your brain. And below it, the architecture of a CNN. It's not just some vague idea. The structure is a direct mimic. It processes information in a series of layers, just like our brain's visual cortex does. All right, let's get into how this whole thing actually builds understanding. How does a machine go from a meaningless grid of colored dots to recognizing something as complex as a cat? Well, it does it one small, simple step at a time. So the most important thing to get here is that it's a hierarchy. The very first layers of the network, they don't see a cat, not even close. What they do is scan the image with hundreds of tiny little digital magnifying glasses, or filters. Each filter is a specialist looking for just one simple thing: a horizontal edge, a specific color, maybe a corner. The next layer doesn't even look at the original image. It looks at the maps created by that first layer, and it starts combining simple edges into more complex shapes, like curves and circles. And the layer after that combines those shapes to find parts like an eye or a whisker. Until finally, the last layer looks at all these assembled parts and says, yep, that's a cat. And listen, this isn't just a convenient analogy. It's exactly how it works. Researchers have actually peeked inside these networks and found that as you go deeper, you find digital neurons that become specialists. Just like parts of our brain are hardwired to recognize faces, deeper layers in a CNN get really good at spotting eyes, or hands, or car wheels, which lets that final layer make the big picture call. Okay, this is all really fascinating from a tech perspective, but so what? Why does it matter so much? Well, because giving machines a reliable sense of sight has unlocked a complete revolution in technology. CNNs are just ridiculously good at what they do. They get incredible accuracy because they figure out the important features all on their own, no human handholding required. And this power, it's being used everywhere. It's in self-driving cars, helping them see pedestrians and stop signs. It's in medicine, where an AI can help doctors spot tumors in scans way earlier and more accurately. It's even running behind the scenes on your favorite apps. And because they're so efficient, this tech can run on everything from giant data centers to the phone in your pocket.
And this really just brings the whole story full circle, doesn't it? We started with a blueprint perfected by millions of years of evolution inside our brains, and from that, we've engineered a digital reality, a whole new kind of sight that is already changing our world in fundamental ways.
It's just an incredible achievement, and it all started with a simple question about how we see a cat, which of course leaves us with a final, much bigger question to think about. Now that we've successfully modeled one of the most complex parts of the brain, what's next? What other human marvels are we on the verge of decoding and recreating?